Okay, so hi, I'm Void. In this video, we are going to clear the firmware text screen, not to make it look clean, but to understand how UEFI works. Before we write any code, there are three concepts you must be know with it: the system table, console output, and the clear screen operation. So if you understand these three things, the rest of UEFI stops looking mysterious. So what is system table first? When if your application starts, the firmware does not wait for you to ask questions. It immediately gives you a pointer. That pointer is the system table. It is the firmware saying, Here is everything you are allowed to use, not more, not less." If something is not reachable, like through the system table, you should assume it does not exist. So let's ConOut. Let's talk about that. Inside the system table, there is a file called ConOut. This does not mean screen, like it means simple text output. This is important. UEFI does not promise a GPU. It does not a promise to a frame buffer or something. It only promises that text output is possible. So let's get what clear screen really is. So ClearScreen is not a global function. It's a function pointer stored inside the ConOut protocol. This tells you something important. UEFI does not expose behavior directly. It exposes interfaces and behavior lives inside them. Now let's write some codes, and see how this mental model maps to actual C syntax. So I will open Visual Studio Code. So first I will say include UEFI.h. So while I'm writing this header does not give me functions, it gives me agreements. This file defines fundamental types, struct layouts, and calling conventions. Like firmware and application must agree on these definitions exactly. If they don't, the program might be compiled but it will fail silently at the runtime. This will prevent that class of failure. So after this, I will say include library UEFI so this is a convenience layer, like if itself is extremely low level, this library gives us helpers like print function. Important mindset, so nothing like in this file is required. Everything here can be replaced with the direct protocol calls. For now, it lets us focus on understanding struct, not boilerplate. So the last one includes if sorry library UEFI boot services table lib.h. I'm including this even though we won't use it today because it's reinforced the idea that UEFI is table driven. Like you don't call firmware globally, you walk tables, you follow pointers, you will see this pattern repeatedly. So I will say if is status, then if API, then UEFI main. So UEFI does not scan your binary, it expects in this exec symbol with a signature. The firmware knows nothing about your code, it only knows that how to call this function, what arguments to pass, and what return type to expect. So this is a strict contract. So let's do parameters in if we handle image handle, then in if it's system table pointer system table. So let's stop here and talk about the system table. Earlier we said the system table it's a capability map. Now let's be more precise. Like this track is allocated by the firmware, is initialized before your code runs. Is this code is owned by the firmware. You do not create it, you do not modify it, you only consume it. This is a trust boundary For a practical example, imagine you want output text. There is no global print, no global console. There's only system table. You will say system table to console output to function pointer. We will look at it later. If any link in that chain is missing, text output does not exist. So we will say print text before clearing the screen. Then we will say gbs stall for 123 123 for 5 seconds because like we want to see the things, or we can do 3 seconds, you know. So we need to do a fe status and call it status. Then we will say status system table, and then so this is a pointer, so we will access like this, and we called about ConOut, so then clear screen, then again system table ConOut. I will explain this. So I will say if error status, then I will say return status. Okay, so now let's dissect this precisely. Like this system table is our entry point. Without it, there is no path to firmware service. The ConOut is this protocol instance, like not a function, not a global object. A protocol is a struct containing function pointers, retracing capability. This capability is text output. So clear screen. This function is a pointer inside the protocol. It operates on this specific instance. That's why we pass ConOut. As the first parameter, there's no implicit context. So what actually happens, let's talk about that. ClearScreen does not touch hardware directly. It asks the firmware to reset output state. It asks the firmware to like reset the output state, clear visible characters, and reset the cursor, and restore the default attributes. How this happens depends on the firmware, and that is the UEFI provides. Like, so let's print something. We will say print after cleaning screen. Then I will wait for another 3 seconds. 1, 2, 3, 1, 2, 3, and return if he success. So at the start we said the three things matter: system table, ConOut, and clear screen. Now you've seen the high level idea and low level mechanics. You don't call firmware, you navigate structures and call through them. This is UEFI. So let's test it, and before that I want to say that so system table is a pointer. We are in like when there's a struct, we are saying like x dot equals. We will do something like that if there's a struct, but this is not a string, this is pointer. But this is not a struct, that's some pointer, so we are doing this. V equals 32 like this. So system table is a pointer. We are going to ConOut, and then we are going to clear screen, saying the same thing. Okay then, so let's test. I will save this. For that, EDK2. I will open terminal in here. Then source this. Make the base tools. Okay, then I will build it. Okay, so it's done. Let's search for .efi. There it is. I will copy this in here and test. I will, if, okay, there's some, if it boots. So, okay. Now, text before clearing the screen. As you can see, there's things. And after cleaning screen. Now, everything is gone. Let's try that again. As you can see, even the Tiana core thing in here, but after cleaning screen, everything is clean, but there's only our text. So yeah, in the next video, we will extend this model, cursor control, like more things. Everything built on this system table. If this made sense, you are thinking like firmware. Thanks for watching.